New package with PCBs just arrived, and it's really good to make yet another PCB project because I haven't made anything, I mean any electronic project that include PCBs in quite a while now, so let's make one today. In one of my last videos I showed you how to build Arduino on a breadboard, and I told you that I want to design my own Arduino board. And here it is, very simplified version of Arduino UNO, slightly modified by me, so that you have additional connectors for 5 volts, 3.3 volts and GND, because those are very useful and I missed something like this on the original Arduino. Also, this is very simple to build for anyone, even total beginners with soldering, because I used mostly THT components. THT means through-hole components. Those are super easy to solder. There are just 2 SMD components, and those are the 5 volts and 3.3 volts voltage regulators. And if you know that you will power this board only with 5 volts and you are not going to use 3.3 volts, you don't even have to solder them. So that way it's even easier to solder, but still this board, even with those 2 SMD components, is super easy to solder. And I'm pretty sure anyone can make it. Also, I think it's pretty fun to build your own Arduino and understand how exactly everything works right here. If you want to buy one of these PCBs, there is a link to Tindy Store in the description. And now let me show you the schematic and PCB layout. I have been using KiCad for over a year, I think, but for this project I decided to go with Eagle, because Eagle is completely different right now than it was before. Right now the Autodesk changed a lot in Eagle and it's a lot more user-friendly. I quite like it, but I still prefer KiCad for a lot of reasons. The one thing that I really like in Eagle is how you manage libraries, because it's way easier than in KiCad, but KiCad is open source and free, you can do whatever you want in KiCad. Eagle is just for students. Fortunately, I'm still a student, at least as for now. So let's open Eagle, and here is my schematic of this project. As you can see, it's very simple, not a lot of components. It's also very clean. I like this schematic and this layout. We have 2 LEDs, some additional power, standard Arduino headers right here, filtration for the voltage, 3.3 and 5 voltage regulators. And that's pretty much it. Oh, also a reset button, and here is the crystal with capacitors. And that's it for the schematic. Let's now go to the PCB view, and here it is. As you can see, also pretty simple. We have 2 layers. There is also a lot of jumpers. I avoid them as much as I can. Here is the connector. I think it's called DC connector or something like this. Here you can connect the VEN, so that's a voltage above 5 volts. Here we have 2 voltage regulators, some resistors, LEDs, capacitors. Here's the Atmega crystal, again capacitors, headers of the Arduino, those additional headers that I told you about, 5 volts, 3.3 volts and GND. And the reset button is here. Here is the connector, the standard, just like in Arduino, I think it's called ICSP or something like this, and here you can program this board. You also don't have the USB that's usually here, and you have the standard hole so that you can attach this Arduino anywhere you want. So as I said, I designed this project in Eagle, and I ordered the PCBs at jlcpcb.com because they are the sponsor of this video. JLC-PCB is a PCB factory with years of experience. They not only produce standard 2-layers PCBs, but also SMT stencils, multi-layer PCBs. They can also do PCB assembly for you. All you need to do is to upload your Gerber files to their website, choose color of the solder mask that you like, and change some settings if you need to. And that's it. You are ready to order professionally manufactured PCBs for as low as $2 for 5 boards, not bigger than 10 by 10 centimeters. Visit jlcpcb.com to learn more. Link is in the description. And here I have all of the parts for this project. We have some headers, including colorful headers, of course PCB, Atmega 328P, crystal, some capacitors, LEDs, resistors, one diode, 5 volt voltage regulator, that's the SMD component. one button, and DC connector. You can buy all of that without the PCB for about $3, I think. As always, it is a really good idea to start soldering with the smallest components, in this case this small 5V voltage regulator. It's not really that small, but it's still SMD component, and for some beginners it may be a little bit hard to do, but you wouldn't be able to use the DC connector that way to power the Arduino with voltage over 5V, so you can only power it with 5V without this voltage regulator. So I will start with this voltage regulator, then I will move on to probably capacitors, LEDs, resistors, and at the end I will solder headers. And here's one thing, I decided to use this kind of headers, those are male headers, instead of the female headers, because first thing, I don't have female headers, it turns out, because I already have a plan for which project I will use this Arduino, and in that case I prefer to have a male headers right here, but if you prefer normal standard like in Arduino headers, feel free to solder them, it's up to you. And DIY Arduino is ready. As I told you, soldering that is super easy. It took me probably like 2 hours, maybe even less, and that's including moving the camera, so we can probably do it in an hour without any problem. The one component that I miss is this SMD voltage regulator for 3.3 volts. I don't have it here because I already know that I am not going to use 3.3 volts on this Arduino because I already have a plan for a project with this thing. And now I will connect it to my lab bench power supply because there on this Atmega should be still a program for the breadboard video, and probably this LED, I think the red one, should blink. So let's turn it on. I will set it to 9 volts, that's probably a good voltage. And now I just need to connect this DC connector. And here you have it. Green LED means that Arduino is turned on because it's just connected to 5 volts. And this LED is controlled by pin number 13, I think. And as you can see, it works pretty fine. So now I will connect it to computer and maybe build just a very simple project to show you what you can do with this thing. So here's what I made. I have DHT11, that's the temperature and humidity sensor connected to the Arduino, as you can see, and also LCD screen that's 4x20 or 20x4 LCD screen. And as you can see here, I have the temperature and humidity, and if I will just hold the sensor like this, you will see the humidity rising and also the temperature. Right now the circuit is powered with USB ISP programmer that is connected to this ICSP connector, and here, thanks to this additional connectors, GND and 5 volts, I'm able to build this circuit without a breadboard. With normal Arduino you can't connect 5 GND pins to a single board, so you have to use breadboard, And also I can just power this thing. Oh, this cable just disconnected. I can just power this thing with 12-volt power supply. Here it is. As you can see, we can also see the temperature and humidity, so it works just fine. And that's it for this video. As you can see, my simple, very simple weather station works just fine, and thanks to this Arduino it was super easy to build because of these additional connectors, and it was also really fun and entertaining to build this thing. And you can learn a lot. If you have no experience at soldering, it will be still very easy to solder for you, but you can learn a lot about not only soldering but actually how Arduino works and every single component, which is great. I hope you enjoyed this video. Thank you very much for watching. If you have any questions, leave them in the comments, and don't forget to check out links in the description. That's it. Thanks for watching. Keep making. Bye.